All right, I will do problem 5 with you. That will leave you guys 6 problems to do on your own. So remember, we write our coefficients. How are you?
Good, how are you?
Good. All right. Our strategy on these. The very first thing you need is a 1 in row 1, column 1. Okay, so that very first corner has to be a 1, and we have it. So then we get all other column 1 values to 0. So that's where we need to start here. I need to get both of those to be a 0. Charge your Chromebook though. Okay, so for the second row, we have a positive 3. So think about it. If you were going to use elimination, we need to use row 1 to do it, because that's the row I'm not changing right here. If you wanted to eliminate, you would have to take the first row times, just think, if you had an x and a 3x, and I told you to eliminate x, you would take the first row times negative 3 and add them together. So that's what we're going to do. We're going to take negative 3 times the first row and add it to the second. I don't think that output works. The center one in the back does, if you want to see. Sorry, I have no idea. It's never worked in here. There's so many outlets that do nothing. Okay, so we're not changing the first row. Second row, so negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 1 plus negative 3 is negative 6. Negative 3 times negative 5 plus 1 is 16. Negative 3 times negative 18 plus 6 is 60. Are you guys okay with how I got that row? Alright, we also need to change the third row. We're trying to get that to be a 0. We want to use row 1 to do it, so what would you do? So 1 minus 1 is 0. 3 minus 1 is 2. Negative 2 minus negative 5. So negative 2 plus 5 is 3. Negative 13 minus negative 18. So negative 13 plus 18 is 5. Did that load right? Still not. Alright, so column 1 is done. Now we're going to do the same thing with column 2. So we need to get 1 in row 2, column 2. Then we'll get all other column 2 ones on the diagonal, then we get our 0. So, if I want to get this -6 into a 1, what is the easiest option for getting a 1? It will work every single time. So we're going to take row 2 times -1/6. So row 1 doesn't change. 0 times -1/6 is 0. -6 times -1/6 is 1. 16 times -1/6 is -8/3. 60 times -1/6 is -10. And we didn't change the last row. So we have our 1, so now we have to get both of these to be 0. To do that, I'm going to be using row 2, because that's the row I'm not changing. So we need to add or subtract multiples of row 2 to get there. So how would you get a 0 in row 1? Just do row 1 minus row 2. So 1 minus 0 is 1. 1 minus 1 is 0. -5 minus -8/3. So -5 plus 8/3. -18 minus -10, so -18 plus 10. Didn't change row 2. Okay, row 3. Think about if you were going to eliminate. You would have to take row 2 times what? These are like variables. This is like saying a 1y and a 2y. So if I told you to eliminate y, you'd have to take this row times -2 and then add them together. So I'm going to do -2 times the second row and add it to the third. Alright, you guys get that row. So if we do -2 times 0, 0 plus 0 is still 0. -2 plus 2 is 0. So it would be 16/3 plus 3. So you get 25/3. 20 plus 5 is 25. What do we need next? Column 2 is done. In row 3, column 3. Easiest way to get a 1, it works every time. You multiply by the reciprocal. So I'm going to take it times 3 over 25. So first and second rows don't change. So you get 0, 0, 1, and 3. One final matrix, and then we will have our answer. In each column you get the 1, then you need the zeros. So if I'm looking at the first row, we have to use multiples of row 3 to get there, because I'm not changing row 3. So if I were going to eliminate, I would have to take row 3 times a positive 7/3, and then add it to the first. 0 plus 1 is 1. 0 plus 0 is 0. -7/3 plus 7/3 is 0. -8 plus 7 is -1. Row 2, if I want to eliminate the -8/3, I would have to take my third row times the positive 8/3 and add them together. 0, 1, -8/3 plus 8/3 is 0, -10 plus 8 is -2. So that tells me x is -1, y is -2, and z is 3.